Okay, we're solving exercises of the plotting workshop, and this time we're going to discuss the logarithmic function. Logarithmic functions are easy to identify. They have a log in the formula, and the way we solve them is converting them into exponential functions. Only that once we convert them, what's going to happen is that we're going to have to work in the table of values with y's. Those are the ones that we're going to substitute. Okay, so which numbers do we put on the table of values? And is there some other kind of things that we need to analyze in this case? We're going to see that in here. Okay, so the first thing we're going to do is we're going to copy the argument, which is the part that is after the log. Okay, we're going to copy the argument and equalize it to 0. So the argument in this case is 2x plus 4. So what we're going to do is we're going to put 2x plus 4 and equalize it to 0. Then we need to figure out which number is x. So we're going to move stuff from one side to the other one with the purpose of figuring out the value of x. In this case, the answer is -2. Now, what is this thing going to be? This is going to be the vertical asymptote of the function. Logarithmic functions have vertical asymptotes. So we're going to put that information in our step 1. It should look something like this. Once we have done that, the next thing we're going to do is try to convert this logarithmic function into an exponential function. How are we going to do that? Well, we need to copy the formula, which appears in there in blue. Okay, and what we're going to do is, once we have the formula, in this case it's logarithm of 3, 2x plus 4 minus 1. We need to pass anything that is outside of the logarithm to the other side. We need to leave the logarithm alone. So that -1, we're going to pass it to the other side as a +1. Okay, once we have done that, then what we're going to do is follow the following process. This 3 is going to be raised to the exponent y plus 1 and is going to be equal such answer to 2x plus 4. It's going to look something like this. 3 raised to y plus 1 equals 2x plus 4. That's how you're going to transform the logarithm into an exponential function. Okay, now once you have done that, what we're going to try to do is first flip to the other side. Okay, flip. We're not going to move anything. We're just going to flip with the purpose of creating a formula for x. Okay, once we create that formula for x, that is the formula that we're going to use in order to solve the exercise. So this +4, we're going to pass it to the other side as -4, and that 2 that is in there, we're going to pass it to the other side in order to divide the entire expression. Okay, so this formula that you see in here, that is the formula that we're going to use for the exercise. This is going to be our, let's say, fy in this case, because we're going to use y in order to find x, something like that. So that is the formula that we're going to use. This is how the process should look like. So like I said, this is the formula that we're going to use. And from this formula, okay, from this formula is where we're going to see which numbers we're going to use in the table of values. Okay, from this formula, what we need to do is copy the exponent, okay, which in this case is y plus 1. Yes, so we're going to copy y plus 1, and we're going to equalize it to 0, same as we did with the argument of the logarithm. Our goal in this case is to find which number is y. In this case, it will be -1. So that number is the one that we're going to use on the table of values. In the process, what we're going to put is -1 in the table of values on the part of y. Okay, we're not going to put it on the center. We're only interested on one number behind that one, because normally this is an exponential, and normally with exponentials we're going to get a lot of fractions. So we're not too much interested in the fractions because they are very difficult to put in a graph. So we're just going to leave one number behind that. So one number behind -1 will be the number -2. After -1 instead, what we're going to have is number 0, number 1, and number 2. Okay, those are the numbers that we're going to use. Okay, so with that in mind, what we're going to do next is substitute this formula that we have in here and use it in order to find the answers of each one of the missing values on the table of values. Okay, So first number we're going to substitute is -2. So let's do that. Here, instead of y, we're going to use number -2. So we're going to put x equals 3 raised to -2 plus 1, and we copy the rest of the equation. We're going to continue performing this operation. -2 plus 1 will be -1. Then we have 3 raised to -1. Okay, negative exponents, just transform this into a fraction, so it will be 1 over 3. 3 raised to 1 is 1 over 3. Okay, -4 divided by 2. Okay, we need to subtract this. Now, how do you subtract fractions? Okay, well, what you do is, if I have 1/3 and I try to subtract 4, what you do is first you transform this into an equal fraction. You can do that easily if you multiply with the denominator that is on the other fraction. So if I do that, this 4 times 3 will give me 12. And the denominator will be the one that I used. You can notice that 12 divided by 3 is the same 4, so I am not changing anything. It's the same number. But now that they have the same denominator, I can subtract. 1 minus 12 will be -11 over 3. So that's the number that I'm going to use as an answer in this exercise. So 1 over 3 minus 4 will be -11 over 3 divided by 2. When you divide a fraction, okay, like you already have a fraction, but you're dividing it, all you have to do is multiply the two denominators, and that's it. So the answer will be x equals -11 divided by 6. That is a fraction that is a little bit complicated to use, so we probably will not use it to make the drawing. So now that we found -11 over 6, we're just going to copy it as an answer, but like mentioned before, probably will not be used. We're going to continue with the next number, which is -1. And we're going to substitute same way. Instead of y, we're going to put -1. So -1 plus 1. Copy the rest. -1 plus 1 will give me 0. Now, 3 raised to 0, if you remember, any number raised to 0 always gives 1 as an answer. Doesn't matter which number it is. If you raise it to 0, you get 1 as an answer. So once we have done that, all we need to do is subtract 1 minus 4. So 1 minus 4 will be -3 divided by 2. And 3 divided by 2 is 1.5. So the answer will be -1.5. This is a number that we can use. So on the table of values, we're going to put -1.5 for number -1. Then we're going to proceed with 0. That's the next number that we're going to substitute. So on the formula that we have been using, all we need to do is change the y with 0. So 3 raised to 0 plus 1 minus 4 divided by 2. X equals 0 plus 1 is 1 minus 4 divided by 2. We don't need to put the 1, so you could skip it because 0 plus 1 is 1. It makes itself invisible. So we can subtract immediately. 3 minus 4 will be -1 divided by 2. And -1 divided by 2, we already know that the answer for that is 0.5 negative, because 1 divided by 2 is 0.5. So that's another number that we can use. So we can copy it on the table of values now. It will be -0.5. Then we can substitute number 1 next. And substituting it in this case would give us x equals 3 raised to 1 plus 1 minus 4 divided by 2. X equals 3 squared minus 4 divided by 2. We know that 3 squared gives us 9 as an answer. So we're going to put x equals 9 minus 4 divided by 2. And 9 minus 4 gives us 5. 5 divided by 2 is 2.5. Okay. So with that in mind, we can now continue copying that answer, which is actually a really useful answer. So on the table of values, we're going to put 2.5. The next number we're going to substitute is number 2. So let's substitute it on the formula. If I substitute number 2, on this case, I'm going to put x equals 3 raised to 2 plus 1 minus 4 divided by 2. Now, 2 plus 1 is going to give us 3, and 3 raised to the power of 3 is going to give us a big number. So most probably we're not going to use this one. 3 raised to the power of 3 is 3 times 3 times 3. That's 27 minus 4 divided by 2. So this subtraction of 27 minus 4 is going to give us as an answer 23 divided by 2. Now 23 divided by 2, it's actually easy to calculate, but if you're not sure on how to do this, or you cannot think on the number, you can still manually divide. So 23 divided by 2 will be, well, you divide first this one, right? So it will be 1. 2 times 1, 2. will be 0. Then you move the 3 down, right? This allows us to use number 1. 2 times 1 is going to give us 2. But then we get 1, so we cannot divide 1 with 2, so I'm going to use decimal point. That's going to give me an extra 0. Now this is no longer 1, it's now 10. 10 divided by 2 is 5. That will give us 10, subtracting 0, and that's it. So the answer will be 11.5. So 23 divided by 2 is 11.5. That will be the answer, or the final answer of the table of values, which we're going to put right now. So in the table of values, we're going to put 11.5. Those are all of the answers: minus 11 over 6, minus 1.5, minus 0.5, 2.5, and 11.5. Those are the answers that we're going to put in the table of values. The numbers that we can actually use to make sure to draw this without too many complications are only these 3 points. So those 3 points will be the ones that we could try to use. We could try to maybe use a 4th point like this one, minus 11 over 6. Only that in this case, we're going to have to make kind of like some sort of division, okay? Like we're not going to use minus 11 over 6. We're going to have to divide. So instead of minus 11 over 6, okay, we're going to have to find an approximated number that we could use, okay? So 11 divided by 6 will be 1. This will give us 5 point, and 5. And this will be 8. 6 times 8 is 48. And this thing is going to continue, but we could use 1.8, okay? 1.8 will be like an approximated number that we could use. So we could actually use, well, negative 1.8. We could actually use negative 1.8 instead of the answer that we found in here, which was negative 11 over 6. So negative 1.8 would be like a really useful 4th point to use. 11.5 is way too far, so it will not be very useful. So these 4 points would probably help us to make step number 2, which is drawing the graph of this logarithmic function. So we're going to see that in the next step. That will be basically it for step 1 of this type of logarithmic functions.